of tourism. So with that, let's get started. So data preprocessing, it is a very crucial aspect of concern, and it is very important when it comes to data analysis, machine learning, uh, building models, and even deploying or creating an application. There is no way that will ever work on any project without passing this particular stage. It is important. It is technical at some points, becomes so serious at some cases, and you have to deal with it. You have not to, if you mistake this particular stage, it might cost you a lot in your project, in your publication, in your models, and it might not be reliable as well as might not be something to be proud of. So there are a few things that we'll be looking at, the highlights of today in relation to data preprocessing. These include what is it? What does it mean by when we talk about data preprocessing? We'll be looking at why should we data preprocess our data. We'll get to understand why. Then we look at when should one data process. So when should that particular stage occur in your projects, in your machine learning models, in your analysis? So at least in a way that you have to understand which stage is it applicable. Then how do you do those particular processes? How do you get to data pre-process? Then we'll be looking at techniques of data pre-processing to see which are the various techniques that are applicable and are applied when it comes to data pre-processing. So let's get to understand and get to answer these questions one by one to be able to know what do we mean by each and every sector. So what is data pre-processing? Data preprocessing, in a very simple term, technically, it is the aspect of transforming real-world data to informative data. And what do we mean by real-world data? And how does the real-world data looks like? So real-world data, in any way or in any case, you'll find that it is a correction of very different data, very variety of data that is at some point, in any cases, they are very messy, very inconsistent. They find that they have missing values. They contain errors in a way you get that the data is very unreliable to say so. So in such a way that you really need to work on it, you really need to look at everything in a very particular angle to see what exactly are we doing. So with that said, we have to know why should we pre-process this data. Having seen that our data is messy, the data contains outliers, contain missing values, inconsistent data. Why should we get to preprocess this particular data? Or what is the essence of preprocessing the data? One of the reasons is that data quality. We need quality data to use at any point given. We need quality data in any time that we are applying this particular data. We need an accurate data for that to improve even reliability when we talk about using this particular data. Then we can talk about improving productivity. When we talk about improving productivity, it is now, if you have very reliable data, you have a high quality data set and a very accurate data in line to the project or to your problem statement that you want to accomplish, the productivity will be on high end. You'll at least have a very quality application that you have built, a very reliable analysis of what you have done. And with that, you'll get to see that there is a lot you can get to learn. There is a lot that you can get to see, you can get to understand in any point given of why we want to pre-process this particular data. So the other question that we might want to answer, it is now, when should one data pre-process? So which stage or what particular area, at what point should you get to pre-process data? Because if we get to understand that it is a stage in the machine learning pipeline or in data flow work at any point given, it is that, that we get to see with everything. And we can see that in any point or in any situation that we are dealing with, you need to pre-process data right after acquiring the data. So when you have corrected the data, you've mined your data. The next thing that we're supposed to do, it is acquiring that particular, it is now pre-processing the data. Because there is no other stage that you can head if you are not acquiring that data. There is no other way that there's no other process that you can get effective process or you can get to analyze, visualize, build a model without pre-processing the data first. So that is a key stage in any point given whenever now you are dealing with pre-processing data. So the light time to pre-process data, it is light after acquiring the data. That is what we typically mean when we talk about the light time or when should one pre-process the data. Because I think the first stage of dealing with data, it is outlining or defining clear goals or problem statements of what you want to accomplish. Then you get to the data mining, you get to data correction in any form that you'll be dealing with. And then now the next stage, which is now the beginning of the process, as we might say, is data pre-processing. And you can never skip that stage and get accomplishment, not unless you just received a pre-processed data. But if you are dealing with little old data sets, at any point given, you'll be encountering these particular uh, components of data set of a messy and inconsistent data in union. How to prepare to pre-process data in any case. How do we get to pre-process this particular data? So we get to clean data. We have to do cleaning to the data because it is very messy. We have to do data transformation. This is the aspect of transforming data from one way to another to an effective and useful way that any individual can get to utilize and it gets to depict or give reliable insights at any point given. Then we can talk about handling of imbalanced data. So you'll find that if you're talking about a labeled data set, you might have a virtual butter of classification data set with the target column as an imbalanced data set, or you get a skewed data set that lies on one side and the other. So you find that if you use that particular data set to train your models or even get to do analysis, you might get incorrect insights. Reason being that one of the classes it's underestimated or it's underprovided when it comes to data set. So these are the issues. This is how you get to deal with this particular aspect of pre-processing. Then we talk about data integration. This is the aspect of now integrating data. You might be having several data sets that you would want to combine together, at least to have that particular data set together. This is where you can get to concatenate, you can get to stack the data, even you can get to merge that particular data. In a way, at least they'll get to their point of now achieving, all you get to see, you get to see what exactly you are dealing with at any point given. These are different aspects of how you data pre-process. We talk about feature engineering. These in lines with data transformation in a way, because when we talk about data pre-processing, feature engineering, it is the aspect of now transforming that particular data maybe to new features, to new variables that have more insights or get to give more information. Example of date of birth might not be useful, but the age of date of birth will be much useful at any point given. That is what we talk about when we talk about that. Then normalization and standardization. We might have data that is skewed another way that might have different layers of data. Maybe for numerical data sets, you might be having different data that carries age, another one carries salary. So at any point given, if you fit your data in that particular way to a model, in this particular case is model training, it might get to assume that the salary data or the salary feature carries more weight than the age. Whereas in real sense, you might find that according to your goals or according to your problem statement, the age might be more useful than even the salary. So just because of the figure difference of an age of 45 and a salary of 200,000 might not in line. And if I think that 200,000 is more relevant than 45 years in case. So this is where we get to standardize our data or even normalize our data to just give it or to just put it in the same scale that we can get to, it can be more effective and it can be more useful for any point given in this particular case. That is what we mean for all this particular case of how to data pre-process. So talking about now, other issues that we can talk about is techniques of data pre-process. These include, number one is imputation. Imputation is the aspect of trying to impute missing data, because you'll be fighting this challenge of having missing data sets. And at any point given, you would want to deal with this particular data as either to drop. This is where you can get to use different types of imputation techniques. These include like regression. You can use regressor models to be able to impute data. You can use k-nearest neighbors. This is another model for imputation. You can get to this is the aspect of where you get to use the majority and all allowed that, or what is around that particular missing value, missing entry can be stamped to be maybe that is what's supposed to. So if there's a range of numerical values or even classes, you get to look the nearest neighbor, what's the value of it, and it assumes that what was supposed to be even in that particular missing gap. We talk about hot depth imputation, we can talk about multiple imputation, we can talk about interpolation, we can talk about random imputations. These are just as there are different ways where you can get to impute your data sets where you have a case of missing values aspect. So there are many techniques. This is where we can look at for simple imputer. These are just a slight code of how you're supposed to do. You can import from sklearn.impute. You import simple imputer. Then you can initialize that particular imputer, which is, you call it imputer, then simple imputer equals to strategy. And the strategy that you want to use, this can be mean, can be mode, and even can be, let's say, sum. So it depends with the essence of what the data you're dealing with at any point given. Then from there, you can call out the columns that you want to use this strategy of simple imputing to fill in the gaps that you want to. This include now you can call out df. Df that all comes in for, as a matter of fact, comes in for the data that you want to deal with. Then you can specify the columns that you would want to work with. This, for this case, is an age and salary. Then you can call out now the imputer that you already initialized in this particular aspect of concern, and even specify the strategy that you will want to use for this particular imputation. And then you can fit the data now to this particular imputer. Then after fitting, transform those particular data. So this is just an example of a code snippet of how you get to exploit, or you get to do this aspect of data imputation. Okay, that's how we get to learn, or that's how we get to understand these particular imputations. So there are a few other techniques that are involved. These include duration. When you may be dealing with those particular missing values, you might have to decide, maybe I can do away with this particular entries that has missing values, because maybe the missing value are a lot, maybe even columns. You might find that more than 50% of the entries in that particular column, they are not available. And then it means, and then when you look at it, you get to find that even those particular that particular column might not be that relevant to any case of you dealing with. So you get to say, and you get to decide that in one or the other, I might have to do away with this particular feature or this particular entry for me to have a trace reliable data sets. Then we talk about outliers. This is where you get to detect and get to decide whether you can deal with those particular entries of the outliers separately, or just have to mitigate those particular outliers in a way. So there are a few ways that you can get to deal with outliers. You can get to separate them and deal with that particular data itself, or you can get even to decide to drop those entries with outliers, because they might give you irrelevant, or they might give you skewed information. When we talk about encoding, this is another aspect of concern where we get to have, in any way that we are dealing with training models and we are trying to build a model, we can only feed the model with numerical values. So at any point given, we need to encode the data. This is from string or characters to binary form so that you can go to use that particular case. You will encounter cases of duplicates. This is where you'll have some repeated data set, and it is not of goodness to you when you get to use it in any analysis, because the data might be skewed in one or the other. They might give you irrelevant insight, I mean, because you might find that it's biased, and the reason why it's having maybe it's a summation of a column, and you find that it is on a very high end, or maybe the averages are very high, and you might think that is very good, but in real sense, it is because of duplicates. So at some point, you might be dealing with imbalanced data set, and you might now get to deploy some techniques like oversampling. This is where you get to oversample the minority class just to make sure that all the data set is balanced for you to be able to train or to do your analysis better. We can talk about undersampling. This is where you get now to undersample the majority to be able to be equal to the minority side for the data to be balanced in any case. We talk about synthetic data generation. It's also another way of generating data, just trying to make the data balanced. Then there is other aspect of concern like dimensionality reduction. This is where we have a lot of data, and we have the data contains even the noise, which you find that this noise, in one or the other, it's not relevant to your model, not relevant to your analysis, and you might find, or you might decide to do away with them. So you just have to be left with relevant features of concern. That is what we mean for this particular case. There are other issues that you can get, other techniques. When you talk about integration, you might be dealing with a lot of data set or different data from different classes. So you might decide, for this case, I would want to integrate this data, merge them like I said earlier, a matter of stacking or even concatenating or even merging the data sets. So when we are talking about natural language processing aspect of it, now when we are talking about LLMs, in a way, you might get to these particular stages of pre-processing. This is where you stem or you lemmatize your data, just trying to call it back to its base name or its base word to be able to use and feed it to your models. That's how we get to talk about stemming as well as lemmatization. Then we can talk about tokenization. This is the aspect of also when we talk about natural language processing as activities, we might want to tokenize those particular data trees to have the tokens that are the relevant tokens. This is where we get even to extract and remove stop words that are there, because they might not be creating relevant insights to your model as you train your neural networks aspect of it. Then we can talk about scaling. This is what we have seen earlier, and how do you do it? The aspect of normalizing the data, standardizing that particular data trees to have it in one scale in a way that that particular data will get to understand, I'll get to learn, I'll get to get the insight of exactly what is required. So these are different techniques, including feature engineering. It is the aspect of creating new features or transforming existing features or creating new features from existing features just to create more insight and more relevant data that you can use to be able to train it to your model. So in a way or in one or the other, these are different aspects of pre-processing techniques that you really need to know or really get to understand, for at least for you to be able to understand exactly how does this really happen. So that's what we mean for pre-processing. You need to deal with data sets. You need to really work on it. You really need to clean it. You really need to look at exactly what is it that you want to achieve. And with that case, you'll be able to exactly nail it and be even happier with the outcome of your data in one or the other. That is what we mean for this particular case. And that is the end of my presentation for data preprocessing. At least now we get to understand what is required for us and what we are supposed to do to achieve a clean data that is more reliable and can improve our productivity.